This is the 3D Printing Nerd Print Farm, and it runs on software that I made, Print Farm software, and I'm giving it away for free. Well, you're in 3D Printing Nerd Studios, proudly powered by PCBWay. PCB, CNC, and 3D printing. It's all PCBWay.com. That's right. Print Farm software that I've developed, I'm releasing for free as open source. In fact, if you don't even want to watch this video, there's a link down below to my GitHub where you can go and you can clone the repository. It's got installation instructions. It'll run on Mac or Windows. I think even Linux, because it's NPM, it should. Like, it's good stuff. It's good stuff. I'm going to take you through it though, and I appreciate you going through it with me because I'm really proud of this. Yeah! So we're going to go through it. I'm going to assume that you can go to the GitHub and see the installation instructions. I'm not going to take you through those, but I'm going to take you through the website, my thinking, my workflow, and how it works out. So to start, my goal of writing this was because nothing else worked for what I wanted. I have Prusa printers, but Prusa Connect does not work well for what I need. Bamboo has a farm software as well. I think Grant at 3D Musketeers talked about it a while ago. I didn't get a chance to watch that video. My goal though was to be printer agnostic in a way and to just maximize throughput and be as efficient as possible, with the goal being that our run of XRP kits for SparkFun, we could then use this tool that I've created to be better about running it. The computer can keep track of counts and the operator can take care of the printer, and everything just works together. Let's go through it. So what you're looking at is the dashboard of the 3DPN Print Manager. At the top, you can see your utilization, and that's because not all machines are running at this time. You get a parts today, a parts count over 24 hours, you have your time, and that little circle in the upper right is the refresh. It's the polling. It's not consistently polling all of these machines. It runs at a configured time. And again, this is local network. This does not have a cloud component. This does not have a login. This exists within a private network. This is the dashboard. Yeah, I talked about the things at the top. So below that is fleet status. And you can see I've got Core 1, Mark 4S, and XL machines. Green means the print has finished on that machine and it needs to be harvested. Blue means it is still printing, and orange means it needs my attention. Usually it means that filament has run out, and so we'll have to go take care of that. And below that, it gives you the active projects. So within my farm software, projects have parts. Parts have quantities, and quantities in parts are fulfilled using G codes for multiple machines. But right now, again, we're printing the XRP kits, and for July, we've got the printed solid filament and box 4 and box 5 below that. The green status bars show that that part is complete, meaning a quantity for chassis of 50 was fulfilled, so it's 100% done. You can see some of the bars are blue, and what that is taking into account parts that are currently printing. So the farm software is going to assume success, but it never confirms it. A human operator has to confirm success. So the blue is currently printing, and it means when the blue turns green and those parts are done, they'll turn green. And once the operator confirms it, it locks that in and closes out that part. And if all parts are green and confirmed in a project, it closes out the project. Well, let's go over to the fleet view. 45 printers awaiting confirmation. Yeah, a bunch of printers have finished and they're waiting for an operator to go and harvest the part. And then as you can see on these various 3D printers, there is a green set ready button and a red bad print button. That is the operator confirming whether or not the print was a success. Now, the green button just says, great, success. The part has been logged. The count is updated. We are good. If you were to press the bad print button, it goes through a workflow where it will decommission the machine. You can see that 02 and 11 are at attention because those are the ones that most likely need the filaments. You can see the blue ones, 29 and 30. You can see the blue bar about halfway through. You can see the file name, which printer it is. You can also see the material and the color. That is a way of segmenting 3D printers for usage. So under printers, these are all of the printers on the farm. And I can multi-select if I want to, for example, all of the core ones, if I needed to do a bulk change for the material or the color of material. Easy enough. If we go into, say, Applejack, then it gives us stats on the printer itself. And Applejack, since running this software in early April, I'm dog fooding it here, 71 jobs have run, 257 parts have been made, a 96% success rate has been had, and that's over the course of 311 print hours. And then below that, you've got an event history. It tells you the jobs that have been completed and when they've been completed. And it tells you if the printer lost the network connection, which some of these Prusa machines do a lot, and when the network connection was recovered. You've got failures, you've got recommissions, you've got all sorts of incredible things. And then the job history right below that with the time and everything. Data is key here. This is kind of where we get into the crux of why I built this. Within the project view, remember, there are projects have parts. Let's go to the first July printed solid box. So if I click on it, it then brings up the project view and it shows everything as being completed for the first box. And if I hit the details on a part, this is when it's kind of really cool. It's showtime. So you can see that the chassis here, we have 50 and we need 50, which is why it's at 100%. G-code files then are associated with each part. So with this chassis part for the XRP kit, I've got G-code files for the Mark IVS and for the Core 1, meaning it will send out G-codes to those printers as it needs it in order to build to the quantity that it needs. So then the Mark IVS and the Core 1s on the print farm will mix in order to bring 50 of these chassis prints.
Now that's cool.
I can scale really easily. And if I need to add a different machine to the farm or a different series of machines, then I just add the appropriate G-codes for those and we're good to go. Let's go here because this is the project that is currently printing. Within this view, you can see that the chassis has a little bit of blue on it, and that is because one is still printing. Again, we have 49 and we need 50. Below that are the G-codes, and you can see that I am targeting PLA material and gray for these, which means that if you have 3D printers with different materials or different colors of materials on your farm, you can then target these. So let's say you needed 1,000 of something and it didn't matter the color. You would specify the material that you wanted, for in this case, PLA, and then any for color, and it will just farm that out to every machine it can that has PLA until you get 1,000. Next to that though, is cool because you have group selectors. So each printer can belong to a group. I could have the groups per shelf or per row. Everything is possible because then it gives you more discernible data in order to target the machines that you want to print your parts. And then if you want to add something, you just click here, upload your G-code, and then you specify how many parts per plate there are. Real quick, let's go back to the fleet view. So you can see on MK4S10, it has parts per plate of 25, but that 25 it has a little selector next to it. So the software knows that in a run on a 3D printer that may have more than one part per plate, let's say one of the 25 fails, you can specify that you have 24 out of 25 that were successful. And it keeps the counts updated and it makes sure you always have enough parts available. I wanted to make sure I showed you that. Now let's open up the wheel and the battery clip because these don't have any Mark IVS or Core 1 3D printers assigned to it. These are both on the XL. The XL 3D printers on the farm are just continually pumping out the wheels and the battery covers for these projects. It's great because of the large build plate. It works on parts that aren't very tall, but take up a lot of space. Being able to create a project, you can just do a new project and you can give it a name and you can add parts to it. But for me, it was going to be really valuable to be able to copy a project. So let me show you. So I just hit the copy button and then I'm going to name it because it's going to be the XRP kit, July, XRP, and it's going to be box 6. And I'm going to hit duplicate. So it puts box 6 up here. You can grab the little handle and put it down there. And then it's a draft. So you can see active, you can see completed, you can see paused, you can also see draft. So let's click on it. And it looks good. The copy is always going to make it a draft in case you don't want to make it active yet. And here's where it gets interesting. If we look at the dashboard, the blue is showing you what's currently printing. And once the blue is done, everything will be green. And once we, on the fleet, confirm everything with the green button, there's going to be no more jobs for those 3D printers to do unless within projects, we can set this next job from draft to active. There are already 2 3D printers that it identified that were idle. 20, good, and 17, good. So you can see that those were finished like these, but those were cleared. The red or green button was hit, and then there were no more jobs. So it just sat at finished, waiting for something. And what we did is we just activated a new project, which then gave those 2 3D printers something to do. So if we go to the dashboard, here we go. Box 6, chassis, 2 are starting to print. That is so cool. The jobs list is all of the jobs. And I do have a work item to better encapsulate this, but these are all of the jobs, 3,735 jobs so far on the farm since April. But you can sort by status, by project, and by 3D printer. And having data is incredible, but being able to display it in a meaningful way is still something that I'm working on. Next is decommissioned. So the idea being, if a 3D printer, for any reason that's in the farm, can't operate as a farm machine, you can decommission it. And that brings it into this area with a note as to why you decommissioned it. The Centauri Carbon, I've been trialing it and the Centauri Carbon 2 for the farm. My Centauri Carbon 2 has a networking issue and I decommissioned it. Mark 4S 27 and 38, those have problems with the bed cable. So these printers have done hundreds and hundreds of hours of 3D printing. And so on those 2 machines, they got min-temp errors on the 3D printer, and it said it was because of the bed cable. So I just have to replace the bed cables on those. Down below is settings. At the top, import printer registry. So initially, what I did with all of my Prusa machines is I put their the name and the IP and the API key, the group and the type in a Google Doc, and I exported it as a CSV and I uploaded it, and that's how I got my farm started. And it was via that import printer registry right there. I haven't kept that up, but my goal eventually is to make it so you can download a template to be able to enter your information in. Below that is add a printer. You would go to printer models, and under connector, you've got Prusa, you've got Elegoo SDCP, which is what the Centauri Carbon uses, and you've got the Elegoo Centauri Carbon 2, which uses MQTT, which is actually the same as what Bamboo uses. And I can communicate with Clipper machines. I just hit up Moonraker. So what you would do is pick the connector and then give it a model ID and give it a label. And I've done it for these machines up here. Once you do that, you can, via add printer, pick the connector, pick the model that you've done, and give it a name, an IP address, an API key. For Prusa. I think for Clipper, it's, something different. For Bamboo, a little bit different. For MQTT, for SDCP, a little bit different. The idea is each class of machine has its own connector as a go-between. So print farm functionality knows how to do this stuff. Connector knows how to talk to the 3D printer. They talk to each other. Below that is dispatch settings, and I have that set to 5. And I did this because the networking on the Prusa machines can be flaky. And so I found that if I do 5 at a time, I'm not overwhelming the network, I'm not overwhelming 3D printers, I'm not overwhelming the computer. What it will do is send jobs to the first 5 printers that it has available. And once those are printing, it'll then send it to the other 5, and then another 5, and then another 5, eventually filling out the farm. That's what the dispatch setting is. You can also back up your farm. It stores locally, again, locally on a machine, but it wouldn't hurt to export it every once in a while. I am gonna put some redundancy in at some point. It actually may be before it's available to download from this video, but we'll see. Polling is every 15 seconds, and I have that set there, and I don't have that configurable. So that is the print farm manager. I need to go and get more filament on 02 and 11. Why don't I take you with me? And then as I hit buttons, you'll see that change on the screen. Here we go. Here's number 2. We have a filament out scenario. So we take that out, we hit the button, filament was unloaded correctly, yes. So while that warms up, let me get some filament ready. Life on the farm, life on... Okay, I'm putting it in. We gotta wait for the temperature to go. So let's go to number 11. Here we go. It's this one. Filament out again. Take that out, hit the button. This filament was unloaded successfully. I'm gonna take that and we're going to put some more filament in. What'll happen is that one back there, it'll start spitting out filament and ask me to confirm if the color's good. And while it's doing that, I can get this one ready to go into this machine. There's the little thing. I'm gonna hit yes, and then I go, whoop, just like that. Okay, right there, once the polar refreshes, you'll see O2 go from yellow to blue. Yes, it's good, and then I just go whoop, just like that. Now once that goes, okay, once the polar refreshes, number 11 should go to blue. You know, number 22, Mrs. Cake, plenty of filament. That is done. Let's try something. So let's pull the print from Mrs. Cake. There we go. That's good. And now let's go back to the software and hit the green button for number 22. We know that everything is either printing or fulfilled. So hitting go and the green button on 22 should mean that it will start printing part of box 6. And we should see this +2 go to +3. So let's go to 22. Set ready. Okay, we've hit the button. It's now communicated with the server. And if we go to the dashboard, we see a +3 because it sent that file and it's gonna start printing the chassis for box 6. I want more people to be able to find the joy in print farming. And if my software will help you, it's free. It's totally and completely free and open source. If you want to take it and make something with it, do it. I would love, love, love to see that. I'm thinking of like the kid with 2 or 3 machines in the garage. Maybe they've got a Prusa Mark IV and a P1S and maybe an A1. And with those 3D printers, they could start a manufacturing business using free software that I provide. Free! The software itself, I'm gonna do my best to add features as I need them or as I get feedback. And if you have a request for anything, let me know. If you have any questions, reach out. I will continue to update it as I can, but again, I'm excited. If you've made it this far, you're awesome. Don't forget to hug each other more. Fight for a cause you believe in. Print all the things! And as always, high five.